Yeah. So in today's topic, we'll be discussing about K nearest neighbor classification, which is one of the most important classification method and also easy to understand classification method, right? So the name itself, it says that it's a K nearest neighbor classification, which means the K indicates a particular value should be given here, and the name also says that it is something nearest neighbor classification. So based on the nearest neighbors, it will classify the a new set of points. So this picture depicts a small understanding of what is happening in KNN classification. So you can see we are having an input value which looks similar to a cat here, right? So we are in a KNN classifier. Already we are having a training model like what is a cat and what is a dog. So whenever I give this input, it is trying to predict what is the output, that is a cat, because of the features whatever is available in the input picture. So it is saying that this belongs to a cat class, right? Yeah. So now moving ahead, yeah, as I said, KNN algorithm is a very simple and easy to understand machine learning concept. Okay, so it is basically both a classification and regression problem, but however, it is mostly used for classification problems. Okay, so KNN has other name called as a lazy learner algorithm. So in most of the examinations or most of the questions asked, they can ask you questions like explain about lazy learner algorithm. So you need to recall that whenever they talk about a lazy learner algorithm, it indicates that it is a KNN algorithm only, that is K nearest neighbor algorithm. Okay, yeah. So why is it called as a lazy learner algorithm? So it is called as a lazy learner algorithm because it doesn't require any predefined input values. Okay, and also there is one important thing which we need to learn about KNN algorithm, because it is mostly suitable for small data sets. So if you are having a vast data set, it takes a lot of time to make some predictions and make some classification models. Okay, yeah. So KNN algorithm at the training phase just stores the data set, and when it gets new data or new input value is given, it classifies that data into category that is much similar to the new data. That's what happened here. Here we had seen there are two pictures or two identical images of cat and dog, and whenever the new input value is given, it is trying to map with the available input pictures, and it is predicting the output that it is belongs to a cat. So likewise, it has many real world applications. Okay, yeah. So moving ahead, this is a small pictorial representation to understand what is something before KNN and after KNN. Here you can see there are two graphs between x1 and x2. We are having some set of points colored in yellow and green color, and which belong to green belong to category A, and yellow belong to category B. And you can see a small new set of point called which is indicated in blue color, right? So there is a blue dotted point which is a new point. So before KNN, it doesn't belong to either category A or category B. That is something a new point. Now the main role or the main theme of KNN is it need to identify into which class does it belong to. Okay, yeah. Let's look into that slowly. Yes. So now the role of KNN is to segregate this or to classify it into either class A or B. Now, if you are looking at the second graph after KNN, the color of this blue has changed into something similar to green. That means this object belongs to category A. But how does this happen? Right? So this is the use of KNN, that whenever there is a new object which is available, it will try to classify it into either of the class according to the distance or nearest neighbor values. Okay, so moving ahead in the next slides, we'll try to understand how this has happened. Okay, yeah. So talking about features of KNN, that is K nearest neighbor. So KNN belongs to a supervised machine learning concept because it comes under classification where labels are already available. Yeah. So which uses labeled input data set to predict the output of new data points. Okay, yeah. So it is one of the most simple machine learning concept, and it can be implemented for varied set of problems. Okay, yeah. It is mainly based on a feature which is called as a similarity problem. So the neighbors are identified based on the similarity measures. So for that, we are having various distance calculation metrics which we can learn in the upcoming sessions. Okay, yeah. So, so this is a small algorithm like the step-by-step procedure. How does KNN work? So here you can see the step-by-step procedure. In step one, we need to understand first how many neighbors we need to consider. So the first important criteria is selecting the value of k. Selecting the number of k of the neighbors is a very, very important criteria. So once we select the k value, then we go ahead with the calculation of distance metric. So here you can see a name is given as Euclidean distance. That is one of the distance which we have learned in our previous geometry and also when learning about probability. So Euclidean distance is the formulae which is used to calculate the similarity between the neighbors. And in step 3, you can see take the k nearest neighbors as per the calculated Euclidean distance. So you'll be calculating Euclidean distance with a new point and available data points, and whichever the distance values are near, accordingly we need to try to map it into that class. Okay, so that is the step 4. Among the k's, among these k nearest neighbors, count the number of data points in each category. So we need to categorize them according to the distance metric, and whichever point is similar, as you can see in the step 5, assign the new data point to the category of for which the number of neighbors is maximum. So this is the algorithm which we need to follow, and once you are following this set of points, you can say your model is ready. Okay, yeah. So let's go ahead and try to understand about KNN in detail according to the formulae or according to the algorithm what we have discussed just now. So yeah, so why should we learn KNN? That is to categorize the new data point into either of the class. Okay, yeah, as seen in the graph here. So now, as I said, the step one, in the step one, we need to understand how to select the value of k. So if you want to categorize this new data point into either of the class, first you need to identify what is the k value. So for that, we are selecting for this example, we are saying that k is equal to 5. And the second step is calculate the Euclidean distance. So if you want to calculate the Euclidean distance, first of all, you need to know what is Euclidean distance. So Euclidean distance is nothing but it is a calculation between distance between 2 points. The formula is given here. It is square root of x2 minus x1 whole square plus y2 minus y1 whole square. You can see what is x1 y1 and what is x2 y2. Yes, a of x1 comma y1, that is 1 point, and b of x2 comma y2. So distance between these 2 points is calculated using the Euclidean distance formula, and likewise we are calculating the Euclidean distance values for each and every data point, right? So now you can see here, yeah. So once the distance is calculated, you can see the neighbors available. So in the graph, you can see category A, that is 3 neighbors, and category B has 2 neighbors. So according to the step 5 of the algorithm, how should we make a decision? Assign the new data point to the category for which the number of neighbors is maximum, right? So we need to select the maximum number of neighbors. So you can see the category A has 3 neighbors to this point, and category B has only 2 neighbors. So we can easily say that the new point belongs to category A because it has maximum neighbors. Okay, yeah, that's how we need to make a decision for this k nearest neighbors. Okay, so yeah, this looks fine, but here you can ask me one question: how did you select the k value is equal to 5, and why k value is equal to 5 only? Why can't I take it as 3 or 4 or anything? So with respect to that, you need to remember one important point. Whenever you are using the k nearest neighbor algorithm, the k value should always be an odd number. That is one important observation which you need to keep in your mind. So k value is always should be a odd value. Odd value is preferred for selecting the value of k. Okay, then I can use taking the value of k equal to 1 or k equal to 3 or k equal to 5 and 7. Among these, why did I select the value of k is equal to 5? Okay, so there is no particular way that why we should select the k value of 5, but you need to keep a trial, like k, you should take the k value equal to 1, and then k value equal to 3, k value is equal to 5, and among these values, according to the input data set, whichever the value of k gives you best result, that should be selected. Okay, yeah, so always we need to select the higher value of k. So a very low value of k, such as k equal to 1 or 2, can be noisy and it can lead to some outliers. That's the reason always you need to select a value which is not a bit at higher or not very low, a medium or a moderate value of k need to be selected. For large values of k, for example, if I take k value as 9 or 11, so large values for k are good, but it may also find some difficulties. That's the reason you need to select the moderate value. That's the reason we have selected a k value as 5 here. Okay, yeah. So now let's proceed with a small example to understand the concept of k nearest neighbor. Okay, so here you can see a small data set, right? So consider a small data set having two variables, that is height in centimeters and weight in kg, and each point is classified as normal or underweight. So last column indicates the column that's a decision making, that whenever you're given the point of weight and height, it is saying whether it belongs to underweight class or normal class. Okay, so here you can see weight and height values are taken as x2 comma y2. Okay, so here you can see the person is having 51 weight, and if he is having 167 centimeters height, he is categorized as underweight person. Similarly, the person is belonging to 65 weight, and if he is having 172 height, 172 centimeters height, he is categorized as normal. This is how we are having a training data set, right? So now the training data set is available. Now the question is, yeah, so on the basis of given data, we have to classify the below set as normal or underweight. So here we have given a new data point, that is x1 y1. So a person is having 57, weight has 57 kgs, and his height is 170 centimeters. Let's first look whether this value is available in our dataset or not. Let's see a person of weight 57. Here you can see a person of weight 57 is available, but what is his height? So as per the given given new data point, his height should be 170. A person with weight 57 and height 170 is not available, so we cannot directly make a decision. We need to categorize that according to the given data set, and accordingly we need to make a decision. So we are assuming that we don't know how to calculate the body mass index BMI value, and we want to make a decision for this set of given input. So how should I make this decision? So as I said, you need to apply the KNN algorithm. You need to select the value of k, then calculate Euclidean distance formulae, and later according to the Euclidean distance formulae, you need to identify the number of nearest neighbors, and whichever the class is having maximum values, maximum probabilities, then that a class should be assigned for this new data set. Let's look into that in detail. Yeah, so you need to calculate the Euclidean distance using this formula, under root of x2 minus x1 whole square plus y2 minus y1 whole square. That is the formula. And if I take the values or the coordinates as x comma y and a comma b, this is the formula to calculate your Euclidean distance. Okay, yeah. So now this is how KNN algorithm works. So you need to calculate distance between the points. You can see the red color point indicates unknown data point, and the pinkish color indicates the data points which are already available in the given data set. You can see you're calculating distance between these points between D1, D2 and D3. Those are distance between the points, right? So as we said, 57 kg and 170 indicates x1, y1, and the rest of the values are nothing but x2, y2. Here you can see these are the x2, y2 values. First, I should take the x1, y1 value, and calculate distance for the first value. Next, I should calculate for second value. Likewise, how many number of values I am having for that many values of x2, y2, I need to calculate the distance values. Okay, yeah. Let's calculate the distance here. You can see under root of x2 minus x1 whole square plus under root of y2 minus y1 whole square, that is 170 minus 167 whole square plus 57 minus 51 whole square. Square root of this value gives the value as 6.7. That is the distance of new point with d1. Similarly, the distance of new point x1 y1 with distance x2 y2, so it is 13. And next 13.4. Similarly, you need to calculate the Euclidean distance value for each and every data set. Okay, yeah, you can see here the tabulated values indicate the Euclidean distance value for each and every row. We have computed the values. This 6.7, 13, 13.4. Likewise, the complete table of values indicate the Euclidean distance values. In examination point of view, you need to calculate Euclidean distance for every point, and you need to tabulate it something like that and show in very detail. Okay, now you can see here we are taking the value of k is equal to 3 because this is a small data set. We are taking the k value as 3 here. I can take 5 also, but because we are having only 8 to 9 rows here, if I take the value of k, it is very difficult for us. If I take the value of k is equal to 5, it is very difficult for us to make a decision. So I am taking the k value as 3 here, and you can see, yeah, the value 57 and 170. You can see here I am not considering these upper values because they are much far from 57 and 170. So that's the reason I am considering the last 3 values. And you can see if I take k equal to 3 and nearest neighbors is equal to 3, I am having these values and all of them are categorized as normal. If a person belongs to 57 kgs or 58 kg, and if his height is 169 or 173 on 170, then this group indicates that that is a normal weight. That's what is the observation from this part. You can see it in detail, right? Yeah. Okay. Then if I go ahead and make my decision for this particular values, yeah, I am saying that the new point, that is 57 weight and 170 centimeter height, belongs to normal category because majority neighbors are pointing that it belongs to a normal category. Okay. Yes. So moving ahead with next advantages and disadvantages of KNN. So there are some advantages, like as I said, it can be easily implemented for short data sets, right? It makes very simple to implement whenever you are having a small data set. It is robust to the noisy training data set. So even though there is noise in your data set, still it can make some decisions. That's why it is called as very robust for even training noisy data, and it is more effective than it can be more effective the training data is large. If training data is large, still it can be more effective, but calculation of Euclidean distance for each and every point takes a lot of time. That's why whenever there is a large data set, the decision making will be a bit slower compared to other algorithms. Okay, yeah. So talking about disadvantages of KNN, always the value selection of k is very important. If you are not selecting a proper value or the right value for k, it may become a complex problem. The decision making also will be a wrong decision. Okay, the computation cost is high because if you are having 100 rows, and every time if you want to calculate Euclidean distance for every row, it is a bit tedious task and the cost will be increased. That's the reason it is much suitable for small set of data set. Okay, yeah, this is the next example which I want everybody of you to look into. The similar problem, here it's having height and weight in centimeters, and here class label is changing. So here the class label is saying that if a person is having height 158 centimeters and weight 58 kgs, then his t-shirt size may be of size M. And if it is having a height 165 centimeters and more than that, he is become and weight more than 60 kgs, his t-shirt size is L. Now, based on these observations, I want to ask you a question. Predict the t-shirt size of a new customer with height 161 centimeters and weight 61 kgs. Okay, so now you need to calculate, you need to apply the KNN classification algorithm for this example, and you need to calculate Euclidean distance considering x1 comma y1 as 161 centimeters and 61 kgs. So these points are not available in our data set. So you need to calculate the distance between this x1 y1 to x2 y2. x2 y2 are nothing but, yeah, height here is x2 and weight in kgs is y2. So you need to calculate distance between the points from the x1 y1 to x2 y2 for each row and compute the Euclidean distance values. Yeah, something like this. You can see here you are having the Euclidean distance value column here. Euclidean distance value is completed for each and every value. And as somebody asked previously, why should I take the value of k is equal to 3 or k is equal to 5? So here, because I am having training samples, something like 18 training samples, I can take the k value as 5. Instead of taking the k value as 3, here we can take the k value as 5. So with respect to this 5, I am giving some ranks. That is where it is much similar. So you can see 1, 2, 3, 4, 5. If I take the 5 values here, majority of the class label values are saying that it belongs to a category called as M. So I can make my decision like you can see, yeah, as the weight as 61 kgs. So since for the k, if I take the k value is equal to 5, we have 4 class labels are saying that it belongs to category called as medium, and only one point is saying that it belongs to category called as L. So we can make a decision that a person with 161 centimeters and 61 kg weight belongs, his t-shirt size belongs to a category called as M. This is how we need to make some decisions for using k nearest neighbor classification. Okay, is it clear to everyone? Yes. If it is clear, yeah, that's it. And if anything to be discussed, you can respond through the chat or you can give a comment so that I can get back to you. Okay, yeah, that's it about your KNN algorithm. Okay, thank you.